Hello, everyone, and welcome to Into the Terminal. Today, we're going to be taking another look at System D, but this time we're going to focus on the unit files. And there are 6 different types of unit files that we're going to cover, like what they are, take a look at some of them and how they operate. And Nate, you're going to be driving the critical path today. So why don't we...
Absolutely. So I'm using a local VM for this one instead of our usual format. So sorry, I don't have as much control over Zoom and whatnot. So bear with me. But the reason for that is we're going to switch around between targets. Targets are similar to what we used to refer to as run levels, but they're really similarities end at pretty much there, right? There's a lot of differences, a lot of more flexibility within targets. So first of all, I'm going to show you how to list what your current default target is. Now, the default target is what your system is going to boot to when you turn it on, right? So systemctl get default. Also can't copy and paste because this is a VM. Sorry. There will probably be typos. You can see that my current default is graphical target. Now, as you might expect, that means that we're going to boot into graphical mode. This is a RHEL 8 machine with a graphical environment installed, so we can switch into a graphical environment if we want to. However, as Eric and I will agree, maybe not Scott, it's better to run your servers at a terminal, right? Because there's lots of reasons for that. I'm not going to go into right now. So I'm going to show you how to switch that in just a sec. But first, we're going to show you all the different targets that are listed within systemd. So just like everything else, targets are units within systemd. So if I do a systemctl list units and filter for the type equals target, it'll show me all the targets that are available. Now, what did I do here?
Target instead of Targe.
Target. All right. So these are all the targets. Now, these aren't listed in the order that they get hit while it's booting. However, similar to the way run levels worked, there is an order in which your system will hit and meet these various targets as it's booting. So, for example, there's a target called Network Online. If you make one of your services dependent on Network Online, then it's going to do its best to make sure the network is started before it moves on to that unit that's dependent on the network being online. Now, that's not foolproof, right? If the network fails to start, it won't halt boot or something. It'll keep trying and until a predefined timeout, and then it'll start your service anyway. Just keep that in mind. But this is what targets are basically designed to do, right? Now, another thing we can do is we can switch to a target. Remember, you used to be able to do init and then a number, and that would switch you to the run level that you picked. For example, if you wanted to switch from graphical to command line, you would do an init 3, and it would take you to the third run level, which is multi-user, right? Well, systemd has a multi-user target in the same way that init had an init 3. So if we do a systemctl, and the command you want is isolate. I don't know why it's isolate. I could look into why, but whatever. Basically, you're going to isolate yourself to that particular target. And then you just tell it what target you want to go to. Multi-user.target. And it should bring us to, I realize that I'll clear the screen in a sec when I run this. And boom, it's going to bring us to, I had to do it through sudo, sorry. Now we're at the VM console just that quickly as a basic terminal. So if I log in as Nate, put in my password, I should be at, boom, terminal. Now, the next thing we want to do, obviously, if you want to set the default target, you're not going to boot into graphical and then run isolate to switch back to essentially run level 3 or multi-user target. There is a way to change that default. This time I will actually do it through sudo systemctl, and I realize this is probably hard to read. That's why I'm reciting what I'm saying. Sudo systemctl set-default, as you might expect, and then multi-user.target in the same way that we did. I missed the T again. Um, in the same way that we defined the target using um, isolate, same thing. Set default multi-user target, and now it's going to ask me for my sudo password. And you can see it says it's creating a symbolic link to from multi-user target to default.target inside of Etsy systemd system. You could theoretically manually change that, but why do that if the command line tool exists, right? All right, and now we're just going to reboot. With the old init system, you would do like an init 6 that would tell it to reboot. There isn't a target that says reboot because why would there be? Remember the old joke? You used to set the default run level to 6 on someone you didn't like, and then their system would boot up and then it would reboot immediately. I don't think systemd lets us do that as easily as init did. But if we do a systemctl reboot, it should reboot the system. You can see there's the good old boot splash. And what it's going to do now is it should boot me into text mode, multi-user target, instead of graphical now, because before the previous default, as I showed you, was graphical.
So, Nate, while we're waiting for that to happen, just a couple of notes of Unix and Linux history. So we talked about run levels, and in the world of systemd, run level is not a thing, right? We use it to describe for people
Right.
who are familiar with that environment to like allow them to have some concept of what systemd is doing. But in the world of run levels, the run levels were extremely prescriptive. Run level
Yes.
0 was shutdown. Run level 6 was reboot. Run level 3 was multi-user with services, no graphics. Run level 5 was multi-user with services and graphics. Run level 4 was one that you could customize. Run level 2 was one that you could customize, but would be no graphics. And run level 1 was single user mode. So, like, there were numbers. The numbers meant things. But in systemd, um, we can define a target of our choosing and call it what we want, and then also create relationships between targets so that things happen before or after other things. The other thing
Right.
with systemd is its parallelism. So we can have multiple things going at the same time, getting the machine up to our desired target service level.
Right. So there you go. We're at a prompt. If I did in fact, I think so. There's aliases in place that if you run init for backward compatibility, it'll still do the thing that systemd would have done. If I do an init 3, it would have brought me to graphical or terminal. Init 5 would have brought me to graphical. Init 6 would have still rebooted, right? Because there's a lot of people that had sort of ingrained that memory, right? That I don't know. That may eventually go away. Maybe it won't. I don't know if that's a deprecated feature or not, but at any rate, just so you know it's there, but you should probably learn the new commands. So, but yeah, that's it for our demo. Any final words before we transition?
Yes. So don't forget to like. Um, and if you are enjoying the program and want to see more, subscribe, and you'll get a notification when we do more of these or publish more of these. And if you have a friend, you're like, hey, this might be something they're interested in, feel free to share it with them. On the other
Yeah.
side of the transition, we'll be talking about the individual files. So we're going to start off with service units, but then we'll talk about sockets, timers, slices, mounts. I feel like there's one I'm forgetting, Nate.
I lost track of what you were listing because I was busy getting my next share ready. Sorry.
We just talked about
There's a
targets.
bunch.
Maybe I
There's
hit the.
6 of them in all.
But so stay with us as we delve into the unit file definitions used with systemd.
Right, right.
All right,
And we're back.
we're back. So systemd is fueled by what we call unit files, and unit files are things to handle specific system operations. So in just a minute, Nate is going to take us through a service unit. It's probably the one that we work with the most as system administrators
Right.
because it's how we control, manage, and offer um, services on our machine. But Nate, I know that last week we talked about some units too.
We did. So last week we talked about timers and that required creating a service. However, I really glossed over the service piece because the focus was timers, right? So I see there's a question in the chat about just timer question mark from William. Timers we talked about pretty in depth last week. So if you want to go check that out, go right ahead. We're going to touch very briefly on them today. But right now I'm going to take basically the service that I'd made for supporting the timer, and we're going to turn it into an actual service that we can just run. So Eric, if you want to bring up my terminal. There we go. Hopefully this should be easier to read as they normally are. So like I said, last time I created a service and I didn't show you what it looked like. So I'm going to copy and paste what I did last time. Hold on. I did a thing I didn't mean to do. There we go. We're going to call it. So like I said, I am going to modify it. So I'm going to name it something other than it was like timed job.service or something we did last time. So we're going to do job loop.service, right? And these are, just flat text files. Let's copy and paste. All right, now let's walk through what these pieces are, right? Normally this would have highlighted stuff and it didn't. I don't know why, but all right. So the description doesn't matter much. This is just it's from the timed job. It was just a thing I run every 15 seconds. We're not gonna change that because I don't really care that much. But you can. It's ideally you'd put a description in there that tells you what this thing does. The once equals my time job.timer we don't need now because it's not going to be a timer this time around. We're going to change the type. There's lots of different types you can define here. There's types for jobs that will fork processes out. There's types for jobs that will run and exit. That's what this is set to, a one shot. There's a basic one, which is what we're going to set this to, which is basically like run this executable and keep track of it for me. But there's a whole bunch of them. And if you look at the systemd.units, I think it is man page, it'll tell you about the different types you might set this to. So we're going to change this to basic because basic is what this service is. It likes pumpkin spice lattes, right? And the exec start, this used to be job.sh, user bin job.sh, and that was just a job that would run date and then exit, right? And the idea was that I wanted it to output something so that we could see it running every time it ran. This time I've modified it to the same command, except now it runs it inside of an infinite while loop, which is a really, really bad way to like run a service, but it's a really great way to make a service example. And that's what we're doing here. And this wanted by is the target which this should depend on. Now, you don't necessarily have to define this, but if you have a dependency as to where this thing has to be defined, this thing has to run in, you should define it here. For example, if this was a service that needed the graphical environment, you'd probably make the wanted by graphical.target. If it's a service that just needs multi-user functionality, that is the network is up and things like that, then you set it to multi-user target. And you can, of course, make it dependent on whatever you want. All right, so we're going to save this. I'm going to just show you what my job loop looks like. Like I said, it's a while true, do this thing, right? Now we're going to take this service file and we're going to copy it into etc system, the system, and then we're going to enable it. You might remember the -- now from last time around. This tells it to activate the service as soon as we enable it. And then we're just going to go job-loop.service. And if we do a system CTL status on job-loop.service, there you go, it's running. And you can see the output here. It says the time is currently 16:17:00 because these systems are running UTC, I think. And if I run it again, you should see it. It's like every 10 seconds, it'll do it again. There it is, 16:17:10. 16:17:20. So there you go. My service is running. It's that easy. right? All I have is a shell script that runs in a loop. Imagine that that's a service that's actually doing something. It's that easy to write a unit file that'll run this thing. All right. Are there any questions?
No, we're debating server with GUI still in the chat.
Well, we already know the answer. Why is there a
Do we
debate?
know?
There should. Yeah, we do. We totally know the answer.
All right. So if no one's going to ask service unit questions, and we can always come back to it if they come in late, why don't
Right.
we move on to socket unit questions or
Sounds good to
socket
me.
units? So if we bring up my screen share, we can take a look at what one of these looks like. So here on this machine, I can run systemctl cat, which will allow me to cat a unit file. And the one that I want to cat is, and I'm going to copy and paste to, well, actually I can type this, cockpit.socket. Okay, so Cockpit is the web-based administrative interface for this machine, and it is controlled with this Cockpit socket unit. And a socket unit is similar to service in that we are going to run a thing, but it runs it on demand. So notice that in the socket definition down here, we have this listen stream parameter. And so what it says is, systemd, I want you to attach to and listen on port 9090. And when you see connections on port 9090, you should do this. So essentially, when we see that incoming port connection, we run this exec command to start up a service. And then we pass off the connection from port 9090 from systemd to whatever this thing was that started when we ran the service. All right, so let's see this in action. If I process status and look for cockpit, we can see the only thing here is my grep, right? In fact, I'll do it even better. I'll just add a little bit of regex in here. We can see that there's nothing running called cockpit. But if I click over to the web console, and you'll notice that it takes a minute for it to like establish that connection. And then I flip back to my terminal and I run the exact same PS. Now we do have cockpit services running. So when I attached to port 9090 with my web browser, that created a connection request to the machine's port 9090. Systemd was sitting there listening on port 9090, did the exec commands to start up the cockpit service, passed off the connection to it, which then rendered the page for the web browser. And we can see that it's still running here on the machine. And if I terminate my web console window, at some point, we'll see that nobody's connected to it anymore and remove the service from the machine. So we'll have to wait a little bit for that to time out. And I honestly can't remember whether that's a configurable parameter or not. But once the service is no longer used, then we stop systemd goes back to listening on that service port number for new incoming connections. All right, so one more time, let's take a look at the systemctl, or sorry, the systemd unit for it. So we got a description, which is just a nice text-based thing. When we're listing units, it'll show us. Documentation, so it tells me if I want to know more about it, about this specific unit, I should look at this man page. Once, so the cockpit MOTD service wants this unit to be running first. I'm sorry, I take that back. The other way around. This unit wants cockpit MOTD service to be running. Under the socket section, the listen is the key one. That's the port the systemd should listen on. And then the exec commands on what I should do when I see those connections coming on port 9090. There's also an exec stop. So when we're finished with the connection, what should we do to clean up? And then when we install the unit file, where should it go? I'm sorry, let me try that again. What should we install it into? So sockets.target will also include a once for this unit file. So this is how we control transient services on Red Hat Enterprise Linux in the systemd world. Previously, we would use things like the Zinetd daemon or xinetd, which still is shipped, at least with RHEL 8 when I last looked. I haven't checked RHEL 9 yet. But it is also a socket-based thing. So yeah, this is how we control transient services now. And you can write your own for transient services. The trick is, though, when you're writing your own transient service, there will be a delay
Right.
between when the connection is received by the port and when systemd spins up the service to service it and passes off the connection. So there is a little bit of time between when the connection comes in and when it's passed off to the application. So you wouldn't want to do a transient service for something that you expect to be used fairly often.
Right. Yeah, it is. It is a pretty interesting feature, though, right? Especially for things that you're not going to be using all the time, because not only does it free up the resources, it also theoretically can be a security benefit because there's not a process running when it doesn't need to be running, right? This whole like slim down system concept, right? So it's pretty cool. Now, Shantanu does have a question, and I'm kind of wondering the same thing because when I looked at this to prep for the episode, I noticed the same thing that Shantanu has noticed. Um, the exec start is missing. It has all these dependencies, or not dependencies, but the post and the pre, right? But it doesn't actually call exec start. And I think this is because there's also a cockpit.service. And I think the naming links the two together. Although I didn't have a chance to dig into that. I don't know if you did, Scott.
I believe that is correct.
So if you looked
So
within systemd, there is a unit file called cockpit.service, but it's not running all the time. I think that's what I think it by default calls that when someone hits this port.
and so here's the requires,
There
right?
you
So we
go.
have to be running cockpit first, and then a little bit later on, there's this exec start, which is what Shantanu is asking about.
Right. I did find it weird that it wasn't called out directly because most of the time it will be, even though it is a like an implied default. But you know, if it works, it works, right?
All right, and then I saw another question from Aaron about what's the leading dash in the exec lines. I'll have to take a look at the man page, see if I can find that out while Nate is working on the next unit file.
Yeah, there was another comment that suggested that may be if it's present. But if you can find some clarification on that, that might be helpful. All right, let me find what's the next thing I'm doing. Timers. I'm revisiting timers. All right. So last week, like I said, we talked about timers. In that episode, what I did is I went like full bore and I made a timer unit file and a system unit file, or I should say a service unit file, which is called by the timer, which you might argue is like the correct way to do it. There is a quicker and easier way to make a quick timer right from the command line. And there's a command called systemd-run that'll let you do this. And I'm going to touch on it really quickly because we did do timers pretty in depth last time around. This example came straight from a website that I found describing how this works. So you can blame them if you don't like the format or something. All right. So systemd-run is basically a command that says, I want to run a thing with systemd. And we do --on--calendar, which, if you remember, was one of the options that we had in our timer unit file that says when you want to run this thing. Now, the formatting they used is very shorthand here. I'd imagine you can use the same longhand that I did in my unit file. What this says is every minute, once a second, run date, right? I think that's what this is saying. So star, I think, is minutes. 0/1 means every second. Run bin bash or bin sh -c the command date. So it's just going to run date once a second. If I run this, it's going to tell you, hey, this is the timer I created for you. It's going to run it as this service. So it basically did the things that I showed you manually, but it did them in an automated fashion for us here. So now if I do a system CTL list timers, it'll show you here that there is now a timer. I guess it's every minute that that's running, not every second, which is much better. You can see that there's this new unit called run-rc9f yada 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 dot timer, and it's telling me that it exists. It's going to run again in 26 seconds, and there it is. So we went a little more in depth on how to use this list last time around, but if we check here, all right, now it says, hold on, now it should have run again. Yep, it must have just run because it doesn't even have the timer left yet. And here we go. It says that it ran and it's executing, right? So now if I did a -XE, if you remember from last week, we talked about journal CTL. Journal CTL XE will show us the last entries in journal CTL with the extended output. And there you go. It says, that's job loop running. Here is my new service, or not new service, but new timer that I created using systemd run. There it is. All right, and that's my quick and dirty timers, right? This is another unit file you can use. We covered it really in depth last week, so if you really want to learn more about timers, go check out last week's episode.
So next, I'm going to cover slices. So
Get out your
slices
swords.
are how. That's right. Slices are how we integrate into C group, and it allows you to put limits on processes integrated into systemd. And so there's a really good example that's again cockpit related. If we do a systemctl cat on system cockpit https.slice. So this is what's in there. And notice there's a slice definition. This could also be put into your main unit definition, but it gets applied automatically if you have a slice type unit. And essentially what we're doing is limiting how much system resources cockpit processes can consume. So, for example, there can only be up to 200 process IDs assigned to the cockpit service. So when that 201st connection comes in, it's refused by systemd, and it won't start up additional processes to service that request. Memory high and memory max, this is how much memory you're going to allow it to consume. So if it is, actually, I'm going to have to look at that one more time because I'm losing track of it. But essentially, it's putting limits on how much memory you're allowing these cockpit processes in aggregate to consume on the machine. And we can stop them from consuming more memory if they keep going beyond these thresholds. The other things that we could put in here would be things like CPU cycles that we allow it to consume. I think there's also some disk utilization stuff that will allow it to mess around with. But the whole point of slices is to put controls on how much system resources you're willing to devote to this service. So imagine, if you will, that somebody used a robot connect to port 9090 from a whole bunch of different IPs and stuff from around the world. Your system on the other side of that is spinning up a cockpit service connection for each one of those incoming requests. And so if you get to 200 of them, we're not going to spin up any more past that. And it'll keep us from denying other services on the machine access to system resources, memory, and CPU by putting these limits into place.
This is also great for services that maybe could possibly run out of hand, right? I have a friend from my TAM days. He has a great story about how he helped out a customer. They had a security agent of some sort running. I forget what the details were. And the thing would sometimes, when it ran its scan, consume so much resources that it would delay I think it was Oracle's rack, right? That's what Oracle uses to do clustering, and Oracle would identify the node that it was running on as down because it didn't respond quickly enough. And then, of course, that would cause failovers and all kinds of undesirable stuff when it wasn't necessary. And he used C groups through, I think it was through systemd slices, to limit the amount of resources that that particular security agent could run and solve the problem. So, it's a great real world use case of like an actual production outage that was caused by just some agent that was not really confined enough, and adding some boundaries around it.
Yeah, and the other commonly used slice is user slice.
Right.
So that is the C group limits that you would apply to individual users. And that becomes more important when you think about things like um, containerized services.
Mm-hmm.
If they're running as regular unprivileged users, then you may want to make sure that in your multi-tenant system, you're not allowing somebody who maybe wrote a really naughty service to deprive system resources of someone else who may be waiting for some of those resources.
Right.
So you can do like across the users, this is how much memory they can consume on the machine or how many CPU clock cycles they can consume on the machine, which would affect all of their processes in aggregate. Or you can set it on a service level as well. So you can look at specific service stuff. And that kind of plays back to some things we did a few weeks ago around creating container units.
Mm-hmm.
You could set up specific limits for containers running as services.
Yeah, just imagine a user making a container that eats up all the memory and then it starts killing off processes, right?
Oh, Killer is the best.
Yeah, yeah.
All right, and then to round out our 6 different types of systemd units, we're also going to take a look at the mount unit. Now, in theory, you could have systemd mount to your file systems, but practically we don't do that, right? We still rely on things like um, the fstab file for defining those file systems we want mounted. However, maybe if a service is running, you also want to mount some data into the directory tree. That would be a reason to use a mount unit associated with your service. We have a couple examples on machines out of the box. So if I just take a look at a systemctl at on dev huge pages. All right, so this is one that we use for mounting the huge table FS so that we can integrate it into our directory tree and look at some data on huge table usage. So we use these mount units by default in RHEL to attach to some of the kernel memory that is addressable and mountable in the file system to give us access to some kernel information. And here's an example for huge pages. So you can see in the condition path exists. Right, this is one, a conditional, right? So if this path exists, then we'll go ahead and do the mount. But it's also telling us where we can find the data that's being mounted here. So in a second, I'm going to cd into syskernel huge pages and look at it. Under the mount tag, that's where we're telling it the where, right? What device are we mounting there? Type is talking about file system type. So huge table file system has its own file system type. All right, so if I go into syskernel huge pages,
CD, not CE.
I'll do what I want, Nate. You're not the boss of me. Um, so these are the directories that we've got, and this machine uses a 2 meg huge page size. Right, so we can look at things like how many huge pages have been allocated, how many are free, what's the policy on huge pages, like is it transparent, that kind of stuff. This also gets exposed in other places like proc, or at least some of this information gets exposed in other places like proc. So that's an example of mount. We're mounting a in-memory file system from the kernel into the directory tree, and we can access it. Now, there was one other one that I came across when I was looking at this for the show today. So, Nate, I know that you've worked with some other Unixes in the past. Do you happen to remember how Solaris handled temp directory storage space?
Never had to work with Solaris. Sorry.
Uh,
FreeBSD. That's that. Those are my.
what,
That's where my scars come from.
so, other distributions choose to store temp not on a file system, but instead in memory.
Right.
And that makes it so if you reboot the machine, all your temp stuff is gone. Whereas by default for us, we actually store it either in the slash file system, or if you've called out a separate file system ID, it'll store it there. And then if you reboot the machine, it's always there with its data. But we set some cron jobs and stuff to clean it up every 7 days. So what if you wanted your temp file system to be transient? Well, it turns out on other distributions, uh, some of which are distributed by Red Hat, that is the default. So when you reboot, temp is gone, and all the files in temp are gone because it was actually stored in memory.
Right.
So if we take a look at, and I'm just going to clear my screen here real quick. If we take a look at systemctl, and
It's hard to
not enough
type. I
coffee this
know.
morning. All right, we take a look at temp.mount. This is what it has in it. And I want to call your attention to one parameter. Man, where did it go? When I was looking at it earlier, it had a comment in it. It basically says, this is disabled for RHEL. But essentially here under mount, right, it says, we're going to mount it at /temp. The file system type is tempfs. So it's using a in-memory storage parameter. Notice that it does things like set some options on how it should be mounted. And then if you wanted to, you could make sure that it is enabled. But so I think this is used on something like Fedora, if I remember correctly. Some of the Fedora users in chat can correct me if I'm wrong. But we don't use this on RHEL by default. On RHEL, we use disk-based file systems for storing of temp.
Right.
Because with one, if you reboot the machine, everything in temp would be eliminated because you just vacated memory, which is where all that stuff was living. And when you boot back up again, you get new memory, and there's no content stored in it.
We once had a system. I think it was a network service, maybe DHCP or something. I forget what it was. That was getting so many requests, and we were getting this weird lag problem out of it. And it turned out that the thing that was slowing it down was how quickly it could write its log file out. So we ended up having to put the log file on a tempfs in memory, and then we would periodically rotate that to disk, which would then, of course, get siphoned into some other log retention system. So, tempfs in memory. I mean, if you're not aware of them already, if you're having performance problems, they're a great way to make that happen. Or, if you just want temp to go every time you reboot.
Which is how some other, I like Unixes, Shantanu, how other Unixes handle managing their temp. I think it's like fish versus fishes, right? If you have all the same kind, it's fish.
Tomato or
But if there's
tomato.
it's fishes.
Right.
All right. So that brings us to the end of our prepared content today. Nate, any thoughts or words of wisdom before we close it out and talk about next shows?
I mean, the same thing I said last week. Everybody loves System D. And if you don't, you're missing out because I got to be honest. Right? Like I remember all of the hubbub around. We can't change this. It's System D breaks Unix and yada yada yada. It's good. I like it. Sit down and learn it if you haven't, and it's really handy.
Yeah, so in our next show, which is going to be in 3 weeks, so we have a couple weeks off because both Nate and I have some PTO that we're going to be taking in the next couple of weeks. So in 3 weeks, we'll be back and we'll have one more System D episode. And Nate, correct me if I'm wrong, we're going to be taking a knit script managed service and converting it.
Yeah, I think in general we're calling it Advanced System D, but yeah, that's kind of the plan. We were gonna show folks how you take an old style init script and make it work with System D. And we're going to deal with RC local as well. Remember?
Oh yes, that's right, because that one we get a lot of questions on too.
Right.
Of what when do I just want to run a script at boot time and I just want to stick stuff in it? How does that work?
Unixen. That's the one I'm going to use from now on. Thank you, Shantanu.
All right. RHEL Presents is coming up as well in the next couple of weeks, and it's going to be Edge Container Management. So if you're interested in Edge stuff and Edge containers, tune in for that. And then the Red Hat Infrastructure miniseries is Inventory and Identity. So that's the weekly show that Eric and John Spinks have been doing on modernizing RHEL management. They're going to be covering inventory and identity next week. So until then, we'll see you in a couple weeks. Happy Into the Terminaling.
Yeah. Have a great one.